Hello, sir. My name is Nandini, branch aeronautical. My topic is determining probabilities from the joint distribution function. Introduction. The joint probability mass function of x and y is the function e of xi, yi, giving the probability of the joint outcomes capital X equals to small xi, capital Y equals to small yz. Probabilities are combined using multiplication. Therefore, the joint probability of independent events is calculated as the probability of event A multiplied by the probability of event A. This can be started formally as follows: joint probability P of A and B equals to P of A into P of B. Event A equals to the probability of getting a head in the first coin toss in 1 by 2 equals to 0.5. Event B equals to the probability of getting a tail in the second coin toss is 1 by 2 equals to 0.5. Therefore, the joint probability of event when A and B A and B is P of 1 by 2 equals to P of 1 by 2 equals to 0.25 equals to 25%. A joint probability is a probability of occurring one or more independent events simultaneously, denoted as P of A intersection B or P of A and B. One can calculate it by multiplying the probability of both outcomes P of A into P of B. The joint probability distribution of a Bn is used to approximately capture the underlying data distribution rho P, small p. A Bn is completely faithful to P if its structural independencies as a result of the MC cover all and only independencies in P such a Bn is called a perfect IMAP of N. P of A intersection B dash B intersection C dash and P of A dash intersection B intersection C dash plus A P of A dash intersection B dash intersection C equals to P of A into P of B dash into P of C dash plus P of A dash into P of B into P of C dash plus P of A dash into P of B dash into P of C dash. Joint distribution is based on joint probability which can be simply defined as probability of two events variables happening together. These two events are usually coined events A and B and can formally be written as P of A and B. Diagram of joint distribution function. X values are 1, 2, 3, Y values are 1, 2, 3. 1 equals to 0, 2 equals to 1 by 6, 3 equals to 1 by 6. 2 equals to 1 by 6, 2 equals to 0, 3 equals to 1 by 6. 3 equals to 1 by 6, 2 equals to 1 by 6, 3 equals to 0. Joint probability is the likelihood of more than one event occurring at the same time, P of A and B. The probability of event A and event B occurring together, it is the probability of the intersection of two or more events written as P of A intersection B. Suppose that a capital X and capital Y are jointly distributed discrete random variables with joint PMF P of X and Y if G of capital X and Y is a function of these two random variables, then its expected value is given by following capital E equals to G of capital Y comma capital Y. Capital X comma capital Y equals to double summation equals to small x small y capital Y into G of capital X capital Y into G of capital X capital Y. In two random variables that are defined on the same probability space, the joint probability distribution is the corresponding probability distribution on all possible pairs of outputs. The joint distribution can just as well be considered for any given number of random variables. The joint distribution encodes the marginal distribution, that is, distribution of each the individual random variables. It also encodes the conditional probability distribution distributions which deals with how the outputs of one variable are distributed with when given information on the outputs of other random variables. A joint probability is a probability of occurring one or more independent events simultaneously, denoted as P of intersection A intersection B or P of A and B, one can calculate it and by multiplying the probability of both outcomes equals to P of A into P of B. The joint probability distribution of A BN is used to approximately capture the underlying data distribution P. A BN is completely faithful to P if its structural independencies as a result of the MC co- cover all and only independencies in P. Such a BN is called the perfect IMAP of P. Joint distribution is based on joint probability, which can be simply defined as the probability of two events variables happening together. These two events are usually coined event A and B can finally be written as P of A and B. Diagram of joint distribution probability. Joint probability is the likelihood of more than one event occurring at the same time P of A and B. The probability of event A and B event occurring together, it is probability of the intersection of two or more events written as P of A and A intersection B. Suppose that a capital X and capital Y are jointly distributed discrete random variables with a joint PMF of P equals to capital X comma capital Y. If G of capital X and capital Y, P of small x and small y, if g of capital X and capital Y is a function of these two random variables, then its expected value is given by the following expression. Given two random variables that are defined on the map probability space, the joint probability distribution is the corresponding distribution on all possible pairs of outputs. A joint distribution can just as well be considered of any number of random variables. In the formal mathematics set of measure theory, the joint distribution is given by the push forward measure by the map obtained by pairing together the given random variables of the sample spaces probability measures. Thank you, sir.